Okay, since it is 6:15, we are going to start the session. People can join in the middle. We can't be waiting for them, right? So we start the session. Uh, so first of all, a very good evening to all of you. These sessions are conducted by the Coding Club of JNTUHCEH to teach Python to the fellow college mates, and so these are conducted by the Coding Club of JNTUHCEH, and today I will be the primary instructor. And let me introduce myself. I am Nikhil Nandam from third year CSC student, uh, regular, of course. So I will be taking up today's session, and Manas Rao, he is from third year too. He will be taking up the following session. I mean, we will be taking up alternate sessions. Okay, just give me a minute. Okay. Since I've got the confirmation that I'm audible, so without any further ado, let's get started. What will be our agenda for today? So our agenda for today will be learning, or rather, knowing what is a program, what is Python, the history of Python. Then we move on to knowing what is a scripting language, the different features of Python and why Python is becoming so popular, the differences between a compiled versus interpreted language, and then different environments to run Python. So first things first, what is a program? A computer program is a sequence of instructions written using a computer programming language to perform a specified task by the computer. So what does it mean? See, there are a lot of programs running on your computer, right? See, the computers cannot understand our human language. As you know, as most of you know, computers can just understand binary, that is zeros and ones. So we have to make the computer understand uh, the language in such a way that we have to be able to perform certain tasks on it, right? So and also we cannot be just coding, writing programs in binary, right? So zeros and ones, that will be a really tedious process. So we have invented certain languages that can convert uh, the instructions into machine code and then execute those instructions to perform tasks. Okay, so also a computer program is called a computer software, which can range from 2 lines to million lines of instructions. So as you can, certain examples are the Mac operating system. It has about 85 million lines of code, and then the DNA verification software, or something, I don't know exactly. So that has around 2 trillion lines of code, and then Facebook has around 50 million lines of code. So they can range from any number of lines of code to perform the instructions that are wanted by the user or the programmer rather. Okay, so computer program instructions are also called program source code, and computer programming is also called program coding. So the instructions, basically what you write, what you instruct the program computer to perform, are called source code. The programming lines that you write are called source code. Okay, a computer without a computer program is just a dumb box. It is the programs that make the computers active. See, for instance, take the booting of a computer, for example. Let us assume you just started the computer, you just logged in, and you're doing nothing. You think there are no programs running on your computer, right? That's that's not true. There are a lot of programs running on your computer. For example, the operating system itself is a program. When you start your computer, there is certain program that enables the operating system to be loaded. So everything is a program in a computer. Without the computer, it's just a box. You cannot be able to do anything on it. Okay. So next thing, what is Python? Yes, it is, but not in this context. In this context, it is a programming language. As you can see, Python is a general purpose language that is often applied in scripting roles. So, language as well as it can perform scripting. Scripting can be done using Python. Okay, as you can see, as I told, so Python is a programming language as well as a scripting language. Next thing. So, what is a scripting language? We learn what languages are programming languages that support the ability to write scripts. Scripts are often created or modified by the person executing them. So basically, they are just a set of instructions that can be modified during execution. Okay, and one such example of a scripting language is JavaScript. As the, it is indicated in the name itself, JavaScript is a script indicates scripting language. So okay. Games are often written in scripting language. Example, Google Chrome T-Rex game. Uh, okay, there is audio distortion. Okay, so I've been informed that there is a distortion in my noise. Is it audible now? Is it clear? Now is it okay, guys? Okay, so now since it's clear, let's proceed. Let's continue. Uh, okay, so the famous Google Chrome T-Rex game. Most of us have played this game when we have no internet connection or there is poor internet connection. It is just a time pass, right? So that games like those are developed using scripting languages. And of course, Python is an interpreted language. Uh, we will learn what is a compiled language and what is an interpreted language soon in the following slides. So let's move on to the history of Python. Okay, so the history of Python. The Python language was invented in Netherlands in the early 90s by this person named Guido van Rossum. Don't worry, we'll show his image in a bit. Uh, Python was conceived in the late 80s, 1980s, and its implementation started in 1989. So, Python, as most of you will imagine, it is not named after a snake, but a famous TV show called Monty Python. It was very famous in the 1980s. So, this man named Guido van Rossum was very interested in the show, and then so he decided to name his programming language after the show. Oh, just a minute. Technical issues. Okay, so people wanted live chat, so I enabled the chat. I've turned on the chat. Is it open, right? Yes. Okay. So let's proceed. Uh, we've just talked about how Python is named not named after a snake, but a famous TV show called Monty Python, and it is open source from the beginning. Open source in the sense the source code is visible to anyone. It is not like an internal project of a company where only the particular people, employees working in that company or a particular team working in that company has access to the source code, but rather anyone who's interested in viewing the source code can view it. It is hosted on a public viewing platform, like mostly GitHub. Okay, so he is the legendary inventor of Python. As I've said, his name is Guido van Rossum, and one of his famous sayings was this. Uh, Python is an experiment in how much freedom programmers need. Too much freedom can read another's code. Too much freedom and nobody can read another's code. Too little and expressiveness is endangered. What he means is he wanted the programmers to have flexibility and freedom to write their own code, but not in a way that it confuses other programmers, and also not implemented too strictly that it frustrates the programmers as well. So that is what is meant by this. The scope of Python. Where exactly Python can be used and its applications. Python can be used in science, in bioinformatics, and also in system administration. Platforms like Unix and WebLogic and WebSphere use Python. In web application development, also Python can be used, like Django. Django is a very famous framework that is used for developing applications using Python. And also, artificial intelligence is one of the major places where Python is employed. There are, due to the open source nature of Python, there are a lot of libraries that are built for performing various tasks that are in the pipeline of artificial intelligence. Some of those include NumPy, Pandas, and TensorFlow. We'll learn about those, and machine learning, obviously, data science, and testing scripts. So these are the places where Python can be used. So next, moving on to features of Python. So Python is a dynamically typed language. What it means is it doesn't know about the type of the variable until the code is run. Since most of you have filled the form and I've seen the statistics on it, at least around 150 people of you know C, right? So in C programming language, you have to declare the type of the variable such as integer, string, float, double, etc. So in Python, you don't need to do that. The interpreter will detect the type of the variable when it is run. So you don't have to specify it explicitly. Okay. So as we have mentioned earlier, Python is interpreted. So Python is an interpreted language, which means the source code of a Python program is converted into bytecode that is then executed by the Python virtual machine. Bytecode is something like I've mentioned and zeros and ones basically. So the language that the computer can understand. So bytecode is that, and Python virtual machine is the uh, program that runs the Python scripts or Python programs. It is object-oriented paradigm. So object-oriented in the sense it's based on the concept of objects and where each object can contain data as well as code. Data is contained in the form of fields and code in the form of procedures. As you'll move on through the course, you'll get to know that these procedures are nothing but functions, separate functions that each object will possess. Okay, so the features of Python continuation. It is embeddable. So you can include Python scripts in certain tasks and certain environments. So it is extensible. You can extend it, and there are a lot of open source libraries that you can install to get your code working. As I've said, large standard libraries. There is a since the open source nature of Python enables a lot of developers to build libraries that can be used by other people. See, contains a lot of built-in modules as well as third-party open source modules, libraries, and frameworks. Examples include NumPy, Pandas, OpenCV, and requests. So one thing you guys need to do is uh, go to Google, not right now after the session or prior to the next session. Just find out what these libraries do, such as NumPy, Pandas, and OpenCV, and requests. The functionality of each of them and how they are implemented using the Python language. So basic knowledge of what they do is just enough. Okay. So as I've mentioned, Python is free and open source, meaning the source code can be viewed by anyone. Code is available publicly, which can be viewed and updated by anyone. Of course, those updates need not be accepted only those updates that are valid are accepted by the community. Okay, so as I've mentioned, we've come to the stage where we need to know the differences between a compiled language versus an interpreted language. So, starting with what is a compiled language? A compiled language is a programming language whose implementations are typically compilers and not interpreters, as the name suggests. So, these programming languages are implemented using compilers and not interpreters. An interpreted language is a programming language whose implementations execute instructions directly and freely without previously compiling a program into machine language instructions. So basically, the task of a compiler is that it is to convert your source code into a bytecode. And the bytecode is, like I've mentioned, is a code that contains zeros and one, which is a machine understandable language. So this process needs to be done before a code is actually run. So whereas in an interpreted language, the code need not be converted into bytecode prior to running of the code. It can do it on the fly, and there are no two steps involved. It is just a single step that you have to run the program. Okay. So this is a flowchart of how the language source code is just compiled into machine code in the compiled languages versus interpreted languages. Here are a few examples of compiled languages and a few examples of interpreted languages. The examples of compiled languages are C, C++, Go. Go is a programming language developed by Google, Fortran, and Pascal. As you can see, Python interpreted languages include Python, PHP, Ruby, JavaScript. Okay, so just view this flowchart for a minute. Yes, I will share the material after completing the session. We are working on the platforms where we can share, so we will share the material after completing the session. No need to worry. Okay, so moving on. In compiled language, once the program is compiled, it is expressed in the instructions of the target machine. Like I've said, it is expressed in zeros and ones, the target machine, the language that the target machine can usually understand. There are at least two steps to get from source code to execution. One is the compilation phase and then the running phase, which is, like I've said, the source code is just converted into bytecode, which is one step, and then the bytecode needs to be run, which is another step. While in interpreted languages, the instructions are not directly executed by the target machine, but instead read and executed by some other program, which is normally written in the language of the native machine. This other program is sometimes called a virtual machine. So these instructions are not just executed directly by the target machine. They are passed on to another program called a virtual machine. For example, you have a Java virtual machine that runs Java programs, and in Python you have a Python interpreter. So these programs are handed over to them, and those particular virtual machines are responsible for executing the programs. Okay, so moving on again, there is only one step to get from source code to execution. So as I've said, there is no intermediate phase, the compilation phase, where the source code needs to be converted into bytecode. Okay. In compiled languages, compiled programs run faster than the interpreted programs. This is because uh, the code doesn't need to be converted into machine understandable code during the execution, right? It is all done in the compilation phase. So once the machine executable code is ready to run, it is very fast. It doesn't need any more conversions, right? So in that way, compiled programs are run very fast than interpreted programs. In this language, compilation errors prevent the code from compiling. So, during the compilation phase, if there are any syntax errors, the compiler will let you know that there is an error, and then doesn't allow you to move forward. So in that way, you can be sure that the code is correct when it is running. So since the verification is done at compile time, this language delivers better performance since it runs faster than the interpreted programs. Okay, so now interpreted programs or languages run slower because the process of translating code at runtime adds to the overhead and can cause the program to be slower overall. See, like I've mentioned, it takes time for the at runtime the code is converted into bytecode, right? So it takes time for that process to happen, and so that is the reason that interpreted languages are a bit slower compared to the compiled languages. In this language, all the debugging errors occur at runtime. Since there is no checking compilation phase involved where the syntax error is usually done, syntax verification is usually done, so all the errors will be highlighted during runtime. not at the compilation phase. And since there exists no compilation phase, okay, this language delivers relatively slower performance because of the reasons we've already discussed. So the examples of some compiled languages are C, C++, C Sharp, CLEO, and COBOL, etc. And the examples of interpreted languages are JavaScript, Perl, Python, Basic, etc. So we've done with the introduction session. So I think we can start running our Python programs. Are you guys excited to run your first Python programs? Okay, so let's start. Let's get started. So first we need to discuss about the various environments where we can run Python, the places where we can run Python basically. So one thing is Python shell. I'll demonstrate how to use Python shell in a moment. So we'll just see what is a Python shell. This is the place where you can, this link refers you to the Python shell with the official documentation of the Python shell where you have everything in detail. And so it is an interactive environment where lines are input one by one and the output is produced depending on input code. So the Python shell looks something like this, as you can see in the image. So now let's see it in action. Let me demonstrate how the Python shell runs. So you just have to open your terminal. I'm on a Mac, so I opened my terminal. If you're on a Windows machine, you have to open your command prompt. Just type CMD and the command prompt opens up. So you have to install. We will be sharing the appropriate YouTube videos where you can learn how to install Python in your system. For now, just see how Python programs are run in the Python scripting shell environment. So you just have to type Python 3. So first verify you have Python or not, Python installed on your system or not. So for that you have to do Python 3 dash dash version. Once you type in, I can see Python 3.9.1. So I have Python installed on my system. So now what I do is I just type Python 3 and Python, and I'm in an interactive environment. I can see 3 arrows, right? So I can type in first Python program right over here. So the first program we are going to run is printing an output to the screen. That is done using the print function as I'll show you right now. Just type in print with 2 parentheses and include your message within 2 double quotes like hello world. So the first program in any programming language will be hello world, right? So you have to type print and then 2 parentheses and include whatever the string you want to output to the screen in 2 double quotes and then press enter. So you will see the output hello world printed nicely onto the screen. So you can also do this thing, print I am Nikhil and I am teaching Python. See, there's the output. I am Nikhil and I'm teaching Python. So this function takes whatever is input and it just outputs onto the screen. We'll learn more about the print function in just a bit. So these are the different environments where you can run Python. And let me just show you one more example. Don't get confused or tensed if you don't understand what it is. Let me just show you. So let us assume we want to print numbers from 1 to 4, let us say 0. So that includes 0, 1, 2, 3, and 4. So the following program does that for I in range 5 and include a colon, 4 spaces, 4 blank spaces, 1, 2, 3, 4. Print I. And then you have your output 0, 1, 2, 3, 4, nicely printed onto the screen. Don't worry if this confuses you or this doesn't make any sense right now. It will sure in the following sessions. If you follow along in the following sessions, it will definitely make a lot more sense. So this is how a Python interactive environment works. The Python shell works. So once if you want to quit out of this, you just have to type quit and then 2 parentheses and hit enter. So now you're out of the Python shell. Okay. So now let's move on to our second environment where you can run Python programs, and that is VS Code. VS Code is a popular text editing software that is developed by Microsoft. This is the link where you can find the official documentation to the VS Code, and it is an advanced text editor that works with multiple languages and has advanced extensions that can bring the features of an IDE. IDE stands for Integrated Development Environment to the editor. So the features of VS Code include IntelliSense, which is software or rather an extension that is used to highlight color code the program and also suggest functions or variables based on what you type. Run and debug. So you can just run your programs within this VS Code, and also you have specific features that allow you to debug your code. Debugging stands for suppose let us assume your code doesn't work as expected. So you need to find out where the error is. So all that thing comes under debugging, and the rectification of the errors is called debugging. Okay. So it has built-in Git. So I think Git is okay, let me say what is Git. Git is basically a version control software. Okay, let me stop there because if I say more, I think you'll be confused. So basically, you just need to know that Git is a version control software and it has support for Git. So there are a lot of extensions that help you that basically make your workflow easier while running programs using VS Code. So let's see it in action. And VS Code environment looks like this as shown in the picture. So let's move on to VS Code. Oops. So you have to create a new file over here and just type the file name. Oh, wait a minute. You just have to type the file name. So let us name our file hello. And the most important thing, the extension for Python programs is .py. So the extension for C programs is .c, right? So for Python, it is .py. And hit enter, you have created a new file. And so you just have to type the basic print function, print, and then hello world within 2 parentheses. Also include 2 double quotes. And also remember guys, unlike C program, you don't need a semicolon to end your statement. That is one of the features of Python. I mean, most of you might have experienced not including a semicolon at just one line and then breaking your head over the compilation error where the error has been occurred. So there is no such hassle using Python. So you just have to type the statement and you're done. You don't need to include the semicolon at the end of the statement. So first you need to save it, press Ctrl S, and you see this nice triangular box over here, right? So you just press that and you see your output. Hello world printed nicely onto the terminal or rather screen. We can do one more thing. We can just type I am Nikhil and I am learning Python. So it is that. You just have to type your message in and then save it and then run your file. So this is the output. I am Nikhil and I'm learning Python printed onto the screen. Okay, so this is one way where you can run your Python programs. Moving on to the third environment. Pycharm. So this is the official link where you can download Pycharm and also find its documentation. So the extension is Python. You just have to, there is an extension called Python. Don't worry, we will share how to run Python programs in all of these environments. For now, just make sure that everything is getting inside your head. That's it. Okay. So as a Pycharm is an integrated development environment IDE that is simple to use and also includes advanced features. It is a highly advanced integrated development environment, yet its user interface makes it so simple for naive programmers like us to use it. So let's see it in action. And this is what the Pycharm environment looks like. So let me demonstrate how to run Python programs using Pycharm. Pycharm. Okay. So once Pycharm is open, you have to create new project. Select the destination where you need to save the project. Mine will be on the desktop, so I'll just name it hello. And then make sure to uncheck this checkbox. Create a main.py welcome script. Uncheck that checkbox and click on create. So there you have it. Now you are in the project. So once you're in the project, you can see this folder right over here, right? So just right click on it. And then go to new and then Python file. So you can name your Python file. Make sure this is selected as Python file. I'll name mine as hello. So I don't need to include the extension as it is already a Python file. And hit on enter. As you can see, the extension has already been added for us by the environment. And now moving on to our first statement, print hello world. Right. So now that is done, you need to right click on this window and then hit on run hello. See, there is this output printed onto the screen, hello world. Okay, now the same thing, we can do print our message. I am Nikhil and I am learning Python. Okay, so now since we've run this program already once, you can see this right triangular box right over here. So you can just click on it instead of right clicking and then clicking on something else. You just click on it and then you can see your output. I am Nikhil and I'm learning Python. Okay, so this is one more environment where you can run your Python programs. And finally, we move on to our last environment where you can run your Python programs, that is Jupyter Notebooks. Jupyter Notebooks, basically you can run your Jupyter Notebooks in a web browser, but also VS Code has a perfect extension that lets you open and run your Jupyter Notebooks. So we will be demonstrating using of Jupyter Notebooks through VS Code. Okay, so basically Jupyter Notebook is an open source web application that allows data scientists to create and share documents that integrate live code, equations, and computational output, visualizations, and other multimedia resources, along with explanatory text in a single document. Well, I think most of you couldn't understand what that was, but let me explain in simple terms. So this is basically a platform, or rather a software that you can that doesn't simply contain the code, but also you can document the code, right? If even this doesn't make sense, just give me a couple of minutes. I will demonstrate, and then I hope it does make sense. Okay, so the Jupyter Notebooks contain code cells that are used to run code, split into chunks. So you don't have to run your code at once in a single chunk. You can split your code into separate cells and then run each of those cells individually. Okay, and also Markdown cells that are used to document and describe the code. As I've said, this Markdown cells can be used to document and properly describe the code that you have written rather than including it in comments. We will see what is comments in just a few moments from now. Okay, so images can also be included in Markdown. So that lets you properly, suppose you have a flow chart, you can include a flow chart. You have an explanation, you can include an image. You can do whatever you want basically through Markdown. You can include links, you can include headings, you can include subparts, or whatever it may be. You can include, most of them can be done using Markdown cells. Okay, so now let's see it in action. And this is how Jupyter Notebook in VS Code looks like. You'll see this image in a bit. This is taken from the code Jupyter Notebook that I've just prepared for this session. So let's see it in action. Code. So once this is open, let me create a new file. Let's name it, what shall we name it? Printing. Okay, let's name it printing. And the most important thing, your Jupyter Notebooks have an extension of IPYNB. Remember guys, the extension for Jupyter Notebooks is .ipynb. This is different from the .py extension that is used to basically uh, basically used for a Python program. So now you hit enter and then you're generated this cell, and you can type your code over here. Print hello world. Right. So now we have to select this kernel. Don't worry, we will suggest how to do this. So now once this is done, you just have to click on this triangle to execute the cell. And there you can see hello world printed nicely onto the screen. So we can include another message. Python is fun and easy. Right. So you just have to click on it again, and then there you can see the output. Yes, it is .pynb, right? IPYNB. Oh, did I skip the I? So sorry. So it is .ipynb. .ipynb. Okay. So save it and you're done. So let's move on to the notebook that I have created for this session. This is the notebook I have created. As you can see, I have told you that you can include images, right? So this is the image that I've included over here. And then you can see the nice formatting over here, the heading, and then the session, and then subparts divided, and then the documentation. So this is the thing. These are done using Markdown cells. This is code cell right over here. You can also create a Markdown cell by just pressing over here. You have this plus Markdown. So you can add it over here, and then you can basically do whatever you want. Suppose you want to include a heading. Let us say you just have to make it a hash and type in heading and just click on this tick mark. Done, and there's your heading. So there are a lot more things you can do with Markdown cells. It is so that doesn't bother our session right now. So we'll move on to our coding thing. So as I've said, this basic print function is used to print output onto the console or screen. So you can run this, and there you go. There's your output, hello world printed onto the screen. And once this document is shared with you, and you have this Jupyter Notebooks and VS Code installed, you can basically replace this thing with your name. Suppose, let us assume my name is Krishna, let us say. You can type in Krishna and then execute this cell. There you go. This is the output that is printed onto the screen. Okay, guys. So Basically, till now we've just printed strings, right? Strings in the sense a sequence of characters, or basically, let us assume strings are a message. So you want to print numbers. You can do that as well. Just say print and then type in 5. You don't have to include the double quotes or single quotes in that. There is one question. What do you mean by two programs? You mean two lines of code? Yes, you can do that. Let me show you. See, you can do basically two things. I am interested in learning Python. So you can do that. Once you run this, you get both the outputs printed nicely onto the screen. Okay, I hope that clarifies your doubt, right? Okay, so now moving on to printing numbers. As I've said, you don't have to include the double quotes or single quotes while printing numbers. You just have to specify the number you want to print it onto the screen and then execute the cell. So as you can see, I've mentioned 5 and there is 5 printed onto the screen. You can mention 10 and then run, you get 10. You can mention 15, you get 15. So it's basically whatever the number you have mentioned, right? 23. That is assume 23. Okay, 23 is printed. Done. So basically now we've seen how to run integer numbers, how to print integer numbers. So the same can be done on floating point numbers. Floating point numbers are nothing but decimal numbers, right? So let us assume the famous value pi 3.14. So you just have to include the value and then press a triangle. Done. There's your output onto the screen. Any other famous? Okay, we'll do one thing. 123.4.6789. Run it, and there's your output. 12345.6789. Okay. So now, since we've seen what is a print function, if you want to discover what is a print function, you can just use another function called help, and then pass in print as an argument, and click on the triangle, and there you go. This is your output. So this is basically the documentation for the print function. This is value and dot dot dot. Don't worry if this doesn't make any sense. The sep and don't get confused or tensed. It does make sense, and we will explain it to you. What does this sep and end and file and flush mean when we teach about functions and keyword arguments. For now, you just have to know that help is a function that is used to print the documentation of any function, module, classes, or keywords. Okay, so now moving on to what is a keyword and identifier. So keywords are the reserved words in Python. Oh, so keywords are the reserved words in Python, and we cannot use a keyword as a variable name, function name, or any other identifier. They are used to define the syntax and structure of the Python language. So most of our friends who know C programming language will already be knowing what is a keyword. But for those who don't know, you cannot name any variable or a function or any other identifier with the keyword that is specified. So basically, let me tell you in a simple way. There are these two snakes, right, in this logo. So they have decided that I want few words that are used for a specific reason, and if anyone uses for the reason that is not specified, what I will do is I will tell the interpreter to slap them in the face with an error message, so that they cannot do whatever they want. So this is what these two snakes have intelligently decided and have done. So those keywords are nothing but there are 36 keywords in Python. So those words are nothing but keywords. So you cannot use them for any purpose other than you just have to remember that help and keywords included within single quotes or double quotes does the job. So you just have to execute this cell and then there you go. These are the list of keywords that are printed, and there are, as you can count, I think there are 36 keywords. You don't worry, guys. You don't have to remember all of them. False, none, true, pick parser, and as. You don't have to remember all of those. All you have to remember is what each of those keywords does. So most of you will not be using all the keywords at a time. So some keywords are very frequently used. Some keywords are rarely used. So you don't even have to remember the keywords. You will learn most of the functionalities and what those keywords are used for as you progress along the course. But now let us see a few of them and their uses, their intended use. Okay, so now as you can see, def. Where is def? Okay, def is over here. So def is used to define a function. We will see what is a function we have in a later session. But for now, remember that def is used to define a function. Okay, the next keyword, return. Where is return? Why can't I find it? Yeah, okay, return. So return exits a function and also may return a value to the calling function. So as I've said, def is used to define a function and return is used to exit from the function. Don't worry if this is confusing. It all makes sense once you get to functions. As of now, you just have to remember that return is a keyword that is used to exit a function. That's it. And as. Where is as? Okay, here. As is used as an alias. So let us assume you have a variable name or a module name that is large, that is so big. So you just can create an alias for that module. Suppose, for example, one thing will be import numpy as np. So that is a shortcut. Instead of typing numpy every time, you just can use np as an alias for numpy. And then another keyword, class, over here. Class is used to create a class. Like I've said, classes will be covered under object-oriented programming in Python. So you don't have to worry what is a class right now. So just remember that class is a keyword that is used to define or rather create a class. And then lambda. Where is lambda? Okay, over here, lambda. This lambda is a keyword that is used to create anonymous functions. So till now we've discussed about functions, right? So basically these functions are generally given a name, that is an identifier to identify the function. So, but there's another feature that lets you define a function without actually naming it. So that is called an anonymous function, and lambda is used to create such anonymous functions. So now we can move on to identifiers. So what is basically an identifier? An identifier is a name given to entities like class, functions, variables, etc. It helps to differentiate one identity from another. So it is basically naming of things, right? So basically there are around, you have a few, there are people, and how do you identify them? By names, right? So each one has a, I'd not say unique, but each one has their own name through which we can identify different people. Right. So in the same way, we have names for either classes, functions, or variables. And obviously, there will be certain rules for writing or naming identifiers, and we will see each one of those. So the first rule will be identifiers can be a combination of letters in lowercase a to z, or uppercase a to z, or digits 0 to 9, or an underscore. So these are the combinations of letters and digits and the special character underscore that can be used to declare an identifier, be it a variable or a function or a class. Okay, so this is one example where I've named an identifier. This is a variable. Let us say x is equal to 1. Since x is included in the lowercase a to z, right? So it is valid. And there you go. You see the output. The value of x is printed onto the screen. X equal to 1. Okay, let's take another example where we include small letters and underscore characters and also possibly digits. So this is another variable abc underscore xyz underscore 123. That is a that is an identifier used to store the value of 2 basically. So this is also valid since it is not violating this rule that it needs to contain lowercase a to z, uppercase a to z, digits 0 to 9 and an underscore. So let's run this. And there you go. You see your output 2 printed onto the screen. We can include uppercase characters as well. Capital X, Y, Z. Change it to X, Y, Z. Let us put some large number. How many people are viewing right now? 83. So let's put 83 and run it. There you go. 83 is your output. Okay. So moving on to the second rule. An identifier cannot start with a digit. You can include digits in the identifier, but the identifier itself cannot start with a digit. So see, for example, I've mentioned two examples over here. You can include the digits in the way identifier. Run it, and there you go. ABC123. So the value of ABC123 is printed onto the screen nicely. 123 there as you can see. But then if you include numbers in the beginning of an identifier, as you can see, it is highlighted in bright red color. The snakes are angry at me, those two snakes. So if I run it, bam, I'm punched in my face with a syntax error. So sad. Okay, so remember, an identifier can start with an alphabet, which is capital A to Z or small a to Z, or even an underscore. It can also begin with an underscore. For example, let us say underscore ABC, uh, underscore ABC. Run it, and there you go. You have 123 printed onto the screen without any error. So it is basically, you cannot start an identifier with a digit. That's it. You just have to remember that an identifier cannot begin with a digit. Once you do that, there again, I'm punched in the face again with a syntax error. Those Pythons are so cruel, hitting me hard with syntax error every time. Okay, so the third rule. Keywords cannot be used as identifiers. As we have seen, these are the keywords that are used in Python language, right? So these have specific purpose for which they are defined, and you cannot use them for anything else. So one such keyword is global. As you can see, global is a keyword over here. So if you try to name a variable or an identifier as global, you can see this bright red underline over here saying that there might be some problem if you run this. Run, and there you go. Again, a punch in my face with a syntax error. So basically, you should not be annoying those two snakes and be as friendly to them as possible. Okay, so the rule is keywords cannot be used as identifiers. Okay, the fourth rule. We cannot use special symbols like exclamation mark, at the rate, hash, dollar, percentage, etc., whatever it may be, etc. in our identifier. See, these are the only things that you need to include in your identifier: lowercase a to z, uppercase a to z, digits 0 to 9, or an underscore. Only these things can be included as an identifier and nothing else. Like special characters like at the rate and those all will not be allowed or accepted by the Python interpreter. If you try doing something like this, ABC at the rate XYZ equal to 3. Since XYZ is a special character and it doesn't belong to the lowercase a to z, uppercase a to z, digits, and an underscore. So what happens right now? I annoyed the snakes and they punched me in the face with a syntax error. Damn. Okay, so we need to be very careful with the snakes. You know, snakes are very dangerous, right? So, and the last rule, an identifier can be of any length. To the friends who have known or programmed in C language, I think the length of the identifier can be at max 32, right? So in Python, you don't have any limitation like that. The length of an identifier can be anything. Okay, so summarizing all the rules at one place, let's go through all of them at once. Identifiers can be a combination of letters in lowercase a to z or uppercase a to z or digits 0 to 9 or an underscore. An identifier cannot start with a digit. Keywords cannot be used as an identifiers. We cannot use special symbols like exclamation, at the rate, hash, dollar symbol, percentage, etc. in our identifier. An identifier can be of any length. So these are the rules you need to remember while naming a variable, function, or a class. Okay, so now moving on to our next topic, which is statements, indentation, and comments. So let's move on to statements. What are statements? Instructions that a Python interpreter can execute are called statements. Makes sense, right? So, for example, a equal to 1 is an assignment statement. If statement, for statement, while statement, etc. are all other kinds of statements. We will discuss them in the later part of the course. For now, you have to remember that statements are the instructions that are executed by the Python interpreter, or rather that can be executed by the Python interpreter. So, and then we have multi-line statements. Generally, statements are, we think statement is a single line, right? No, we can extend our single statement over multiple lines, and I'll show you how we can do that. One way we can do that is using the continuation character, or rather backslash. So this entire thing will be considered as one single statement by the Python interpreter, though it spans over multiple lines, right? Sometimes your statements may be too long that you cannot include in a single line. You want to split them over multiple lines. So one thing you can do is use the continuation character, which is backslash. Without the continuation character, it will raise an error. See, if you run this, bam, syntax error. This time it bit me hard, man, those two snakes. So let me be friendly to them and include a backslash character so that the snakes can perceive it as a single line, or rather a single statement. And now there you see, there's no error. This entire statement is evaluated 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. All that entire statement is evaluated, and then the value is stored in the identifier, or rather a variable named A. So once you print the value of the variable A, as you can see, you get the value of 45. Done? Okay, so another way we can extend our single statement over multiple lines is using parentheses. If you don't want to, use a backslash character, one thing, the same example is demonstrated over here. You can use a parenthesis to span your statement over multiple lines. The same thing. 45. What happens if you exclude the parenthesis? Punch in the face, syntax error. You're dead. Okay, so make sure to include parenthesis or continuation character when you want to make your statement span over multiple lines, and then run it. Good, you're good to go. You have 45 printed nicely onto the screen. And another example is using square brackets. This is called a list. I suggest not using square brackets right now because square brackets are reserved for a list. A list is a data structure in Python. Don't worry if that doesn't make any sense. We will discuss it in a future part of the course. But now just remember that square brackets are used to denote lists. So as you can see, there are 3 elements in my list separated by that are included in square brackets. And so I named them as colors. As you can see over here, it is showing me that it is a list. We will learn about list and their functionalities in a later part of the course. For now, you just have to remember that it can span the contents or the elements in a list can span over multiple lines. There's no error if you can write it over like this in a single line. There you go. There's no error. See, the output is printed onto the screen. But then if your list contains, let us assume 10 or 20 elements, you just can't span them over a single line, right? It will be difficult for other programmers as well as for you to understand, or rather check the elements once you're working on it. So it is suggested that you span your list in multiple lines like this if the elements are a bit high in number, like this over. Just see. Done. So this is where you can use square brackets and span your statement over multiple lines. Okay, so you can also use semicolons, as you can see over here. This is not like spanning a single statement over multiple lines. This is including multiple statements in a single line. So for that, you can use a semicolon, as is shown here, but those snakes have decided that, seeing a lot of programmers in C struggling with semicolon and compilation errors. So they have decided to do away with the semicolon, right? So don't worry, if you include it, they'll not be angry. They'll print the output onto the screen like this. But it is highly suggested that you don't use semicolon in Python. So the basic idea of Python is to do away with semicolon, right? So again, including semicolon is not generally suggested and preferable. Nonetheless, this is one way you can include multiple statements in a single line using a semicolon. And notice this thing, you don't have a semicolon at the end of the statement. You just have semicolon at the end of first statement and then the second statement, but not the third statement. So this is one thing to note. Like, it is a lot confusing, right? So I highly suggest that you don't use semicolons in your while programming. But it is valid. The snakes will not be angry at you. So okay. Moving on to indentation. So our C programming friends might have known that when you want a particular block of code to be executed, you need to use curly braces, right? To basically indicate to the compiler that this is a single block of code and it should not be separated. So there is nothing like a block of code that is wrapped between curly braces in Python. So it is high. So the creators of Python have decided to not include curly braces to make the code highly readable as well as understandable and a little less clumsy, right? So, but then, how will the interpreter identify the separate blocks of code? So for that, the indentation concept is being introduced. So what is indentation? A code block starts with indentation and ends with the first unindented line. The amount of indentation is up to you, but it must be consistent throughout the block. So basically, indentation is nothing but white spaces over here, as you can see. When I was demonstrating the use of Python through the interactive shell, right? So I've written a loop that also has 4 white spaces. So the indentation is basically necessary. And don't worry if this lines doesn't make any sense. You're wondering what this line does. Don't worry. We will be explaining those in the following session. So for now, you have to know that each block is separated with an indentation like this over here. So you just have to push the block inside with respect to the following or previous block, let us assume. So once you run this cell, you get your output printed onto the screen nicely, 0, 1, 2, 3, 4. And this is the indentation that is needed. So what happens if you don't indent your block of code? Bam, error. Snakes are angry. Damn. They are very strict. They need spaces too. 1, 2, 3, 4. Done. Now I run this. They're happy. 0, 1, 2, 3, 4. They gave me the output. So remember, indentation is very important. And if you don't indent your code properly, snakes will be angry and you'll be hit in the face with the syntax error. Okay. So I think this is the last thing for today. Okay. It is. What's the time? 7:24. Okay. We'll see. Comments. What are comments? Comments are basically a way of telling the language of Python to ignore certain statements or lines while executing the code. So what does that mean? Each of the line does not need to be understood by the programming language, right? Sometimes you need to document the code. Sometimes you can. So basically, you can include a line that basically defines or describes what the function does. Documentation is very important and comments are very important to suppose you're working in a team. You can understand the code you've written but not the other person, right? So how do you make him understand? You include comments. So basically comments are something which you wanted to include and not want the Python interpreter to run it. So how do you include the comments? Comments in Python generally start with hash symbol, the number symbol, right? So there are single line comments in Python, And as you can see, this is a single line comment. This is a comment, and then I have included a hash symbol at the start of the line. And once this cell is run, cool, Python is awesome, great. So what happens if you don't include this comment? Error. Because the Python interpreter will interpret this thing as a statement. So it doesn't understand what is this is a single line comment. It doesn't understand. So once you include a hash symbol and then leave it like that and then run it, that Python interpreter will read the first hash symbol. Acha, okay, this line is not meant for me. I don't have to mess with it. Then it moves on to the next line. Print. Acha, okay, I know what is print. I'm going to print it. Okay. Compare this to your C language, where you have double slashes that generally used to indicate a single line comment, and multi-line comments are in C language are usually denoted using a slash star and then the comment and star and slash, right? So multi-line comments in Python, you don't have anything like a block of comments. You just have to include a hash symbol at the beginning of every line in the comment. So like this. So once you've done this, so the interpreter will take the first line. Acha, okay, it is starting with a hash. It is not meant for me. Then it moves on to the next line. Okay, hash, not meant for me. Okay, hash, not meant for me. Print. Ah, yes, this is for me. I'll do it. So it prints. Hell yes. Python is awesome. Hell yes. Right. Okay, so this is what is a single line comment and a multi-line comments. And then we move on to what is docstrings. So basically, docstrings is a short for documentation string. We will learn more about docstrings when we talk about functions and classes. You can use triple quotes, see like this, 1, 2, 3, and 1 to include your comment. It will be perceived as a string, but it will be ignored by the interpreter. And once you run this, there you go, your output, true. So basically, this is like 3 triple quotes. Okay, the Python interpreter thinks that, okay, I've seen a 3 triple quotes. I have to wait until I see the next 3 triple quotes and then ignore everything that is in between. And then once that is done, I can perform my running the next lines of code, right? So basically, this is the output that is being printed. Okay. So summarizing everything, let's move on. Okay, so printing output. Print is a function that is used to print output on the console or screen. You can print. This is similar to printf, right? In your C language, you just don't have the f. It just basically does the same thing. You just have print and include your message or whatever in the parenthesis. Suppose you want to print hello world, include it in double quotes and then execute the cell. There you go, hello world. Okay, so you can have print numbers as well. You can print floating numbers, that is decimal numbers, integer numbers, and then help is a function that is used to describe or rather display the documentation of modules, functions, classes, and keywords. So this is one thing, help and keywords and identifier. What is a keyword? Keywords are reserved words that have a specific functionality, and those words cannot be used for any other purpose like an identifier, etc. So you can run help with help on keywords that is included between a single quotes or double quotes. Doesn't make much difference. So once you execute it, there you go. You have your output with the list of keywords printed and a few keywords. Def is used to define a function. Return exits a function. As is used as an alias. Class is used to create a class, and lambda is used to create an anonymous function. Right. Okay, so now coming to identifiers. Identifiers. There are different rules for writing identifiers. 5 of them actually. So the first thing is identifiers need to only contain lowercase a to z, uppercase a to z, digits from 0 to 9, and an underscore. Nothing else. No special characters. So, and also an identifier. Moving on to the second rule, identifier cannot start with a digit. It needs to start with an alphabet or an underscore. That's it. You cannot start an identifier with a digit. And third one, keywords cannot be used as an identifier. Like I said, it will throw a syntax error, so you cannot proceed with your programming. So the next rule is we cannot use special symbols like exclamation, at the rate, hash, dollar, percentile, etc. And an identifier can be of any length. So these are the rules that are used for defining or naming identifiers. Remember them while possibly naming variables, classes, and functions. Okay, so the third topic for today, the statements and comments. What is a statement? A statement is a line or an instruction that the Python interpreter executes. And in statements, we have seen how to span a single statement over multiple lines using a continuation character, that is backslash, and using parentheses, and also using square brackets. And we've also seen how to include multiple statements in a single line using the semicolon, although it is not highly preferable, and it is not advised to also. And indentation. And what is indentation? Why we don't have square brackets to define a block of code? Indentation is nothing but generally indentation is four blank spaces that is used to offset the block of code from its previous block to indicate a separate block of code to the interpreter. And what happens if you don't indent your code properly? Syntax error, basically. So that is what is indentation. And comments. Comments are nothing but statements that will be ignored by the interpreter at the time of execution. These statements are generally used for your understanding and usually documenting or defining a function or what a piece of code generally. So the comments are common. A line of comments starts with a hash symbol in Python. Compare this to your double slashes in C. And multi-line comments, each line can start with a single hash symbol, or you can use docstrings that are basically wrapping your comment in triple quotes. Either it can be double quotes or single quotes, it doesn't really matter. So basically, using triple quotes is a docstring, but you can also use it use it for comments. Uh, we will learn more about docstrings in when we discuss functions and classes, but for now, docstrings can also be used as a comments. It will just be ignored by the interpreter. Once you run it, there you get your output. So that's it, guys. Uh, I'm done for today. Any more doubts, please post it in the chat, please. What's the time? Okay, it is 7:33. In the indentation section that you've mentioned, will the code run without the if statement? Yeah. Okay. So you basically want to this right. So now once you run it, it will run. Basically, no issues. But this is a bit confusing, right? So when you're this is one block of code, and this is the other block of code, and this is a comment. So basically, you just have to mention one indentation, one block of indentation, and then this runs perfect as well. No problem. Uh, Recording is available. Uh, Sorry guys, I couldn't record this session due to few technical issues, but I will make sure that all this PPTs and the Jupyter Notebook that I've just used for explaining these topics will be shared to you as soon as possible. I think this Jupyter Notebook contains everything, right? I've tried to include everything in as detailed as possible so that once you view the notebook, you can understand what the below block of code does. So I think that does it. Yeah, I think we since have time. It is still 7:35. One thing I can do is I can explain a few shortcuts in the Jupyter Notebooks, which will be very useful if you are using Jupyter Notebooks. wait a minute. Okay, so this thing. Okay, let's go to the end of this notebooks to demonstrate. This is an empty Markdown cell, right? So you can either have a code cell or a Markdown cell. So the shortcut for converting a Markdown cell into code cell is Y. You just have to select the cell so that it is highlighted in blue and then type Y. There you go. It is converted into code cell. And then you can execute your code over here. Hello world. Okay. Now you can run it. There you go. You have your hello world. Now select the same block of code. Same cell, and then hit M, and then it is converted into a Markdown cell. You just cannot run it. It is used for documenting. That's it. So all of these things are Markdown cells, as you can see. These doc strings. These are not code. These are just a description or a documentation of the following cell that is being done. You just have to type in the document or whatever you want to type in, and hit tick mark on this. And done. There you go. It is properly formatted with bullets as well as the headings. Okay, so one thing is I've shown you how to convert a code cell to Markdown cell and then a Markdown cell to code cell. So one more thing. Okay, instead of every time pressing this triangle to execute the cell, one shortcut to execute a code cell is you can hit Shift and Enter both at the same time. It as well created a new cell for me below it, right? So use Shift and Enter, and there you go. It executes the cell and it moves on to the corresponding following cell. And then you can hit Shift and Enter, and then there you go. Since there is no block of code, there's nothing printed or there is nothing done. Okay, so now another shortcut. Okay, wait a minute. You can do the same thing for Markdown as well. Just hit M, and this is a Markdown cell. Do whatever you want. Type in this is a Markdown cell. You don't have to click the tick mark. You can hit Shift Enter, and then there you go. It is properly rendered, and your pointer moves on to the corresponding cell, the next cell rather. Okay, so now a few more shortcuts. One thing, suppose you are on this Markdown cell, and you want to create a cell above it. The shortcut is you just have to select this cell, this corresponding cell, and then hit A on your keyboard, and there you go. There you have your corresponding cell that is created above your selected cell. And then if you want to convert this cell into Markdown, hit M, and then back to code, hit Y. Okay, so that is how you can create another cell which is created above the corresponding cell that you've selected. So what about bottom? If you want to create a cell that is below the corresponding cell, what is the shortcut? So if you want to create above, you just have to use A, right? So if you want to use below, similarly, it will be B. You just hit B, and there you go. You have a cell below it. The same things. You can convert this into Markdown using M, and then back to code cell using Y. And that's how you can create a cell above the selected cell or below the selected cell. And okay, since now we have seen how to create cells, let's see how to delete a cell. Deleting is a bit not so. Let us assume. See, most people will assume that creating a cell above. Okay, so above A, it starts with A. So let me hit A. It creates. Okay, done. That's good. And below starts with B. So I hit B. A new cell is created. Okay, that's good. But for deleting, guys, the case is different. If you hit a single D, nothing happens. So to delete a cell, you just have to select the cell and hit D twice. Gone. The cell is gone. Select the cell, hit D twice. There you go. The cell is deleted. So again, let's revise the shortcuts. You can convert a cell into Markdown cell using M, and then you can convert a Markdown cell into a code cell using Y. Those are the shortcuts. You can create a code cell above the selected cell using A. Just type A and then you create a code cell above it. You can create a code cell below the selected cell using B. And there you go, you have your code cell below it. And you can, just a minute, this is a markdown cell. Hit shift enter and there you go. So this is a markdown cell. Suppose you want to delete this cell. A single D doesn't do the job. You have to hit double D. D and then D. It's gone. So let us select this cell. D, D. Gone. Undo function, you have control Z, right? Control and then Z. See, I just pressed control Z and then my deleted cell is back displaying and back onto the screen. And if I hit control Z again, there is my another markdown cell that is deleted prior to this code cell. So you can use control Z to undo the deleting of cells as well, not just anything that is corresponding to code. You can undo the deleting of cells as well as the creating of cells as well. If I hit control Z again, there is this new another block. Not another block, the block that is previously code cell that is converted into markdown cell, and then I typed in this is a markdown cell. So you can hit on control Z, control Z, control Z, and then you move back in time. Okay. So that wraps up the session, guys. If you have any doubts, please post it in the chat box. And as I said, I will share this PPT as well as the Jupyter Notebooks as soon as possible. We're just waiting for a platform to share the resources. Are there any doubts? Please post them in the chat box. No doubts? And also the installation of Python, the interpreter, as well as the VS Code installation, the extensions, Pycharm, all those resources will be sent to you soon. Don't worry. Okay, so basically, the assignment for this week is you just have to follow the YouTube videos that will be sent to you to install Python as well as VS Code, PyCharm, and Jupyter Notebooks. And then, how can I Python? I can't download it on my laptop. Okay, so yeah, we will share it. We will share the corresponding YouTube links where they will better explain you how to install Python. So just wait for them, and by the next session, what you have to do is you have to install Python and definitely VS Code, because we will be sharing uh, Jupyter Notebooks which you can use for reference and execute in VS Code, right? So that thing needs to be done uh, prior to the next session, as well as I've mentioned a few things, a few libraries in the PPT, right? Where is this PPT? Let me show you. Hmm. These things: NumPy, Pandas, OpenCV, and requests. What you have to do is you have to Google each of them and just have a basic or brief idea what each of these libraries are used for. So that is the second thing in your assignment. And the third thing is, once you've installed VS Code and configured Jupyter Notebooks in your VS Code, you can, since this notebook will be shared, you have to replace this quadruple X with your name like this, and then run the following cell. That's that does for uh, that is the things you need to do for this week, and that wraps up this session. I really want to thank each one of you for staying patient and participating in this session, uh, very in a very well mannered way. So thank you so much. This is my first session where I'm explaining to other people till now, as an instructor. All these days I've been learning from someone else, but I've never teach to someone. So this is my first time doing that, and probably this will be remembered as an achievement for me. So thank you guys for participating and making this session possible. Thank you. I'm ending this. A great weekend and good night.